So we'll go ahead and we'll move on, remembering, of course, our Aufbau diagram at all times. And this is, oops, not 10. This is 11, 4, 14. Okay. It's a good question to ask, how many orbitals do we have to fill? Is 36 a lot of electrons? 36 is middle of the road. I mean, if you look at your periodic table, we can go all the way up into, 113 is the atomic number of the heaviest known element. We're 118? 118, okay. 113 might be the highest. Anyway, whatever. We don't typically do orbital diagrams for the really, really big, honkin' giant elements, but I typically offer something like, I'll offer a 1-point bonus if you can do, something with an atomic number of like 102 on the test. I don't typically make you do them because they're kind of a waste of time. What we're doing, this orbital notation, is the longest and most cumbersome of them. It's the first one we teach because it shows the detail of what's going on. The next method that we're going to learn is a shortcut. And then the third method we learn is a shortcut of the second method that we learn. So you've now got the big, long, ugly, cumbersome, awkward one, and now we're just going to keep making shortcuts because now you understand the framework you're in. Okay? Okay, so the first method that we learned was called orbital notation, and the second one that we're going to learn is called electron configuration notation. So we're drawing electron configurations in all of them. But the second method that we use is actually called E-configuration notation. Don't get those two things screwed up, okay? What we do when we write this is you just write the sublevel. So 1s is a sublevel, 2s is a sublevel, 2p is a sublevel, 3d is a sublevel, sometimes called subshells. So we write the name of that, and then as a little exponent-like number, we put how many electrons are in it. So same cautions apply about being careful about the order in which things fill, making sure that you draw that Aufbau diagram right off is really important. And why don't we go ahead and we'll take the ones that you did as orbital notations, because you already have those, and we'll shortcut those into electron configuration notation. So you're going from something you've just done into the next thing we're going to do, and then we'll do some more practice. Okay, so we've got our Aufbau diagram, our subshell filling diagram, and we're going to start with nitrogen, which you all figured out has 7 electrons. And you drew correctly the orbital diagram for this, 2px, 2py, 2pz, 1, 2, 3, 4, 5, 6, 7. So this shows each individual orbital. Now what we're going to do is we're just going to show the sublevels and a little superscript to tell us how many electrons are there. So it looks like this: 1s2, 2s2, 2p3. Okay? So we've just taken the number of electrons in the subshell and put it there. It's really easy. Do you have to draw the orbital diagram to get the electron configuration notation? When you're starting out, yes. You won't have to for long. You'll get, I don't have to anymore, because you start being able to skip that step. But when you start out, you'll probably still need to draw the orbital diagram for a while, and then you're summarizing it. And mostly on tests and quizzes, the questions that I'll ask you will be along the lines of, draw all 3. So you're going to have to draw it anyway. Every now and then I'll ask, draw the orbital notation for this one, draw the electron configuration notation for this one, draw the noble gas for this one. When you
say just do one, can we still do all of them?
You can, but circle the one I want. So because then part of what I'm doing is testing to see if you know which one is which. So yeah, if you have to draw the other steps, you can do that, but make sure I know that you know which one I'm asking for. Okay, let's do another one. Okay, so we'll start off with aluminum. It's got 13 electrons. We will start by drawing the orbital notation. 2px, 2py, 2pz. And then we go from 2p, we go to 3s. And then we have to, and I'm going to have to shrink this. So we're going to do the orbital notation for aluminum. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And yes, you have to draw the 3pz, even though there's nothing in it. Once you're in a subshell, you need to draw that whole subshell in orbital notation. So you can't just draw, 3px, 3py. There are 3 orbitals on the 3p subshell. Okay, so to shortcut questions, we're good with this?
I think you have
14.
Except that I drew an extra electron, which would make this silicon? Phosphorus? Silicon, okay. All right, so we've got aluminum drawn correctly now, thank you. So let's do the shortcut. 1s2, 2s2, 2p6, 3s2, 3p1. Good? This one is really easy. Once you've got orbital notation, the electron configuration notation is super easy because you're just summarizing. Okay, krypton has got a whopping 36 electrons. So we're going to run out of room, obviously. So we do our 1s, 2s, 2px, 2py, 2pz. And a couple people said, does it matter which one goes first? No, because we're just writing them in. I mean, we're imposing that x, y, and z on them. They don't know they're called that. They don't care. 3s, 3px, 3py, 3pz. And every now and then I, in my mind, screw up and I write them out of order, but it doesn't matter. What fills after 3p? This is where you have to start being careful. 4s. And we look at our subshell filling diagram to determine that. And with the 3Ds, we kind of give up on the coordinate system and we just identify them by number. Our 3D, what fills up? 4p. So we have 4px, 4py, 4pz. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and then 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Boy, they. You need big sheets of paper. Okay, so if we're going to do our electron configuration notation, it should end with a full 4p subshell. If you have anything else on your paper, it's wrong. Even if I glanced at it quickly and mistakenly didn't catch it, it should end with a full 4p subshell. So this is 1s2, 2s2, 2p6, 3s what? 2. 3p what? 6. Now, here's where we have some small measure of controversy. Do we write 4s2 next because it filled next? Do we write 3d10 next because it's keeping the main energy level together? In the long run, it doesn't matter a whole lot. Your book always corrects it so that all the 3's are together. And what I very often will do is because I do this without writing the orbital notation these days, I write them in the order they fill, and then I go back and fix it. Okay? So if we were going to fix that to reflect having all of the energy levels together, we would have 3s2, 3p6, 3d10, 4s2, 4p6. Okay. Good? So I'm going to give you some time to practice these. Actually, what I'll do is I'll give you some practice, and I'll walk around and spy on you. There are 4 to practice on. Manganese, not magnesium, manganese, neon, oxygen, and calcium. For this, you don't have to write the orbital notation if you don't want. If you want to try going straight to electron configuration notation, you can do that. Anything that has overlaps, though, you have to be real careful. Okay, so the base form for an neodymium, we're advised to write it in a rearranged order. 3d10, 4s2, 4p6, 4d10, 4f4, 5s2, 5p6, 6s2. The thing that does for us is that it shows it very clearly that 6 is the highest occupied main energy level. Okay, FIP quiz is next.